So today I'm going to talk about how we implemented Smart Digest and the Vanquish UHPLC to speed up our peptide mapping in a GMP environment. And so I'm switching gears a little bit, maybe, and going a little bit more towards the low tech. I'm really interested in the multi-attribute monitoring, as we just saw. So that's something that we're moving into. So as I get more into talking about Althea and what we do, you'll see that we have some unique challenges that make a lot of different platform methods really important to us. So I'm just going to give a short introduction to Althea and then talk about some of our background in peptide mapping, give a little overview of what it is, and then how we brought the Smart Digest kits into the lab, and then why we chose the Vanquish UHPLC and how we've implemented that to really speed up our process. So first, Althea, we're a full-service contract manufacturing lab. We're located just right down in Sorrento Valley. We have analytical development, so we support clients from early phase all the way to commercial manufacturing. We have formulation groups. Right now they're doing proprietary crystallomics technology, but they're planning to move into full formulation services. And then we've also just built the state-of-the-art antibody drug conjugate facility. So looking more specifically at our analytical development group, we support a lot of clients. So we have our internal manufacturing department, we have our process development department, and then we also work with our formulations group. And then we support external clients as well. And like I said, these could be anything from early phase development all the way through late phase commercial manufacturing and release. And we really like the early phase development clients. I think that gives us all a chance to do what we love to do, which is develop new methods and bring new technologies into the lab. And it also gives us a unique opportunity to meet our partners early and build a long-term relationship so that we can better support everyone, all of our partners, through the entire drug life cycle, all the way up through commercial manufacturing. And then our antibody drug conjugate group also has analytical development capabilities, which are, their expertise is very focused on the antibody drug conjugates and toxic compounds. So we do have a full range of support. And one of the things that we do a lot of is peptide mapping. So this is one of the, it's specified by the ICH guidelines, so the Q6B guidelines, that this is a way that you can look at the biophysical characteristics of a biopharmaceutical. So we do quite a bit of this in the lab. We can look at characterization, modifications on proteins. We look at the amino acid sequence, obviously. Looking at identity, purity. We do comparability studies, so we do work with some biosimilars. We do look at lots of reference standards compared to each other. And then we're not doing quantitation by peptide mapping at this point, but that is something in our future. And then we obviously do all of this for lot release and stability testing as well. So peptide mapping has some typical steps. So the old school, I guess, peptide mapping would be a denaturation step. And I guess maybe just by a show of hands, who in the room has done peptide maps, tryptic digest? Familiar at least? Okay. Yeah, I just wanted to make sure. So first you would want to denature, and you use a detergent, some type of a chaetrope like guanidine. That's going to unfold the protein so that you can access all of your cleavage sites. And then you want to reduce any of your disulfide bonds, and then you would alkylate your free cysteine groups so that they don't refold as you're doing your trypsin digest. And then you would have a period of time where you would do the digest followed by a sample cleanup to remove any of the reagents that have gone into the reduction and alkylation procedure. And so these steps can take a bit of time. It really varies. So one of the challenges that we have is working with not only a number of clients and proteins, but different types of proteins as well. So we see all types, from very small proteins to really large complex proteins that are difficult to denature, difficult to digest. So sometimes we have peptide maps that take us up to 2 days. So you can imagine that if you have a 2-day peptide map or a 2-day digest, you factor in your reagent preparation time, you can be looking at 3 days before you're getting actual data to anyone. So this is not our ideal situation, especially in an environment where we have process development going on and we have manufacturing campaigns where we're getting samples throughout the process. And in order to continue on that manufacturing campaign, the group is waiting for our results before they can decide what to do next. And so if you can go from 3 or 4 days to get them results to a matter of 1 day, sometimes hours, that would be ideal for us. So years ago, we heard a talk on the Smart Digest, and we probably hesitated and delayed to bring that into the lab. It seemed like maybe it was too good to be true. It also seemed like there were some specialized materials that we needed and we didn't have. So we've been waiting, and we finally got an opportunity to have someone come in, bring it in the lab, show us the technology, and really help get us set up. And so some of these improvement opportunities, I think, were limiting the number of steps in a protocol. So obviously, if you have a lot of steps in a protocol, that every step is going to be a space where you can introduce an error into your final result. And it makes it more difficult for all of the analysts to perform the process. And then reproducibility is key. I guess I have a pointer. Reproducibility is key, and then being able, like I said, to increase the throughput and speed. And then the final thing, one thing that we hadn't considered until we actually brought it into our lab and started working with it, was how much easier it would be to develop a method. So if we have multiple clients coming in with new proteins every time we have to develop a method, and that can take a lot of time. So the faster we can develop methods and the easier we can do that development, the better we can support all of our partners that we're working with. And then this up here I didn't highlight in red, but this is another concern which doesn't affect us as much, but if you were doing characterization of modifications on a protein, this could really affect your results if you're inducing post-translational modifications during your process of the digest. So this is the Smart Digest kit. Pretty simple kit. I'll show in a minute, I'll show the exact method that we used and the exact materials that we had. But what it does, it takes the 5 steps that I showed earlier and simplifies those and brings them down to 2 simple steps. So one is the denaturation, which occurs at heat. And then because your enzyme is heat stable, you can do your digestion at high heat so that your protein remains unfolded. And that way you don't have to introduce any additional reagents and materials to denature or reduce an alkylate. And then the final step is the cleanup. And so this can be as simple as, in our case, we just did a centrifugation to remove the trypsin, which is embedded on beads. There are filter plates that you can purchase, as well as some solid phase extraction depending on your needs. So as I mentioned, we had Thermo. We had a scientist come from Thermo and come into our lab to help us set this up. And one of our case studies that we went through, and we're continuing to look at this more now, so we've had very little time using it so far. But one of the case studies we wanted to see was obviously how fast can we do it? And then what would be our user-to-user reproducibility? So can we take multiple users, some of which don't have much experience in the lab, doing a digest, and can they easily go in and just do the digest and get reproducible results that match one another? And then technology transfer into a QC setting. So sometimes I think, and in our case, our QC lab doesn't have a mass spec, so it's nice and it's easy if we can take the technology, develop it on a mass spec platform, and then transfer it into a different environment where maybe they just have UV for detection. And so we wanted to be able to show that we can actually take this and move it onto another platform, move it into a QC environment, and use it that way. So as I said, this is our initial setup, really simple. In our case, we didn't have a covered incubated shaker, so we needed to use this trypsin, which it's adhered to small beads, so it's in a resin. So each one of these PCR tubes has the aliquoted resin in it, ready for your buffer and your sample. And then it comes with this buffer reagent, so you just add a small aliquot of this to one of your tubes along with your sample, put it in this heat block, which is just a simple PCR heat block that we put in our oven, and then allow the digest to occur. So in the initial development phase, the first thing that you would want to do probably is look at a time course to determine your optimum digestion times. So this can vary. We've seen data where we can do a digest within 10 minutes up to sometimes some of our more difficult proteins that would have taken overnight before can take up to an hour. So far, I think that what we've seen is about an hour is pretty typical for our larger proteins. And then determine if the reduction and alkylation are necessary for your application. So I can't really speak to all applications, and I'm certainly not an expert on the kit and the technology and exactly how it all needs to work for everyone. But I know that in our lab, based on our information, most of our applications wouldn't require any reduction or alkylation. So it's a really simple step process of adding a buffer and then heating and removing your sample and analyzing. So I was really impressed when they came in. We had 4 proteins that we wanted to develop digest methods for. It took us about 8 hours, so it took us just a quick period of time to set up, an hour to digest, clean up the sample, about 4 hours initially, and then we were able to analyze the samples and have results by the end of the night. So by the end of the night, we'd basically optimized and developed methods for 4 different proteins. So if you can imagine the time savings there of going from, say, 3 days possibly to 4 days over time, just to 1 day to have all of this done, that's really nice for us. So these are 2 examples that I can show of the proteins. So these are client-specific proteins, so these aren't just commercially available proteins that are BSA or anything. These are actual proteins that we work with on a day-to-day basis, and we have data backing these up. So the first one is a small protein, which I'll call protein Z, just a 16 kilodalton protein. And this is data from our mass spec, so this is TIC data. And then this antibody, which is obviously more complex. But you can see that we get really good, clean digest, and we get nice peaks off of this. So looking at the reproducibility, we wanted to see if we could have different analysts do the digest, as I mentioned. So for this initial study, we had 2 experienced analysts. So we had a scientist from our lab who's got a lot of experience in enzyme digest and mass spectrometry and years of experience in academia. And then we also had an application scientist from Thermo who came in who's got a lot of experience with the Smart Digest itself. And then we had one of our lab analysts who has a lot of lab experience but not mass spectrometry or experience doing a trypsin digest. And then I thought the best one was a Thermo regional account manager who we buy columns and consumables from her. And so she showed up in our lab, and I told her I was going to make fun of her just a little bit, so it's okay that I'm going to tease her a bit. When she showed up in the lab, I kind of expected for her to come in, say hi, buy us lunch, and then disappear. And she started putting on a lab coat, and I asked her what she was planning to do, and she told me she was going to do a digest. And she would be there for the whole week with John, who had come from Florida as an application scientist. And so at first I thought, I don't know if I like this. I don't know, can you really use any of this stuff in a pipette? But when I talked to her more about it, I was really impressed. And I think this is one thing with Thermo that I've been impressed working with them over the years, is that she wanted to come in the lab and actually do some of the work and be able to better understand the technology that she's selling to all of us, obviously, to better help us and to make sure that she's getting us the right stuff. So I definitely think, her name was Christina Ginty, if you know her, but I was really impressed with that, and she did spend the whole week in our lab doing work with us, so thanks to her for doing that. And so this is our protein Z. So this is the 4 digest overlaid with this one in red, which is the undigested protein. So you can see that we get complete digests. All 4 are really reproducible on the mass spec. So this again is our TIC data. And then the antibody, really happy with this digest. It's a much more complex molecule. So the fact that we could get 4 users who could do this and get almost exact results each time, that was really nice to know. That gives us a lot of confidence in the ability of us to go forward and use this in a QC and a GMP environment. And then now I'll switch gears a little bit and move into the Vanquish UHPLC, which is the platform that we've chosen at Althea as our UHPLC platform. And this is what we wanted to be able to take those initial digests and then transfer those onto the UHPLC and see, can we do a direct transfer, and how fast can we actually speed those up and still get good resolution and great results. There's a couple of reasons that we initially chose the Vanquish as our UHPLC, and I'm not going to go into all of those. I'm happy to talk to anyone afterwards about the UHPLC and some of the things that we've noticed with it. But the big one was just the precision of the data. So retention time precision, as you can imagine, in a QC environment, a lot of our ID comes from retention time. So any shift in retention time is less confidence in a protein ID. So this is 100 injections of BSA that we did a while ago, and 0.02% RSD. And that's pretty typical of what we see for any of our proteins, is really, really tight retention time data. And there's also signal reproducibility in the Vanquish. So I'm going to say I like this graphic mostly because I have a 5-year-old daughter at home. And one thing that I love about kids is that they aren't afraid to tell you what you should tell them. So probably once a week, my daughter asks me if I'll ask her what her favorite color is. And then she goes on about all the benefits of having rainbow as your favorite color, which obviously, as you can see, it's a great color. But this really illustrates nicely, I think, the signal reproducibility. So you can see here there's 100 injections and 600 data points across the spectra. And we're seeing, including all of the background noise, we're seeing average RSDs of less than 3%. And the max that we see across all of this, and keep in mind this is the noise and everything in the background, is less than 9%. So not only is the retention time really reproducible, but you can be really confident in your peaks because your background noise and all across the entire spectra are very reproducible in the signal. So this was the initial method transfer. It was really simple. I kind of expected that we would have possibly some issues somewhere, but our initial thought was, let's just take the gradient from the mass spec, let's use the same gradient and the same run times, and then we used forced air column heating to better reproduce the heating that we were getting on the other instrument. But it was just that simple. It ran perfectly nicely in an HPLC, low pressure, so we get great results. And then the next thing that we wanted to do was see now how fast can we actually do this. So can we take this from what's a 60-minute run, can we get it down to 30 minutes or can we get it down to 10 minutes? And I think you probably know the answer based on all the years of experience with UPLC and UHPLC. But we've done this before, and I think looking at this, I'll back up just a minute. So this is just showing, again, how reproducible the data was on the Vanquish, just with that initial method transfer. And I'll talk more, I'll show some numbers in a minute about the reproducibility. And again, with the antibody, really reproducible data. And then now moving into how fast we can go. So we just doubled the flow rate and then have the gradient each time. And we were able to really easily get it down to 15 minutes. And then with this is the antibody, so we can get this down under 10 minutes and still get resolution between the peaks so that we could get a good idea on the protein and the peptide map. With the other protein that I showed, the shorter protein, the smaller protein, we can get that one down even under 5 minutes just because the peaks are so well resolved. So we can really push that down into the fast run times and limits. So this is just, again, looking at the reproducibility of that antibody in the shorter 15-minute runtime, and you can see that we don't get any shifts amongst any of the different runs for the antibody. And then, as I mentioned, looking at the precision of the instrument. So you can see 4 different analysts started with different stock solutions, did their own digest, and we're getting really good reproducibility of the peak area, considering that we've got 4 different people using this. And then we also have retention time precision, which is even more impressive. So I think that this is one of the important factors to us, is being able to get that positive ID. So almost identical retention times for each of those different components identified in that protein. And then going through our goals, and just to kind of wrap up and conclude, I think I'm quite a bit short. it'll give you a nice break, some time for questions. The goals of the study, so one, how easy would it be for us to implement Smart Digest into our lab? I think I've answered that. I think that it's really simple, even if we had a time course study needed to determine the optimum digestion times. I think for most cases, a day would be enough for us to get a reasonable start to a good digest method and be able to move forward to qualify that for a client. And more importantly, I think that if we just had a generic method that we could use to support our process development group, running in-process samples as they're coming off of the different columns through purification, that would be really useful for us. And to be able to turn that around within a day would be great. So how reproducible are the results? I think I've also stressed this quite a bit. Very reproducible results. We've got 4 analysts with different levels of experience that were able, with almost no instruction and no method, to go into the lab and do this. So that's really nice for us, and the fact that all of your buffers are prepped limits the amount of error that you can put into the method, because there is no buffer prep. There's really nothing for anyone to do. And then the analyst experience, so I told Christina that if I got to make a little fun of her, I was going to make some fun of myself. And it is very simple. Everything's prepared. It's ready to go. And so I've said even I can go in the lab and do it, and I have been kind of out of the lab for a while, so I think we have some people in the room who would attest to the fact that sometimes I can't figure out how to hook a column up to the instrument anymore. So if I can do it, anyone can do it. And after I mess up the column, I figure it out. I can straighten it out by myself. And then the goals, the final goal was how much throughput can we get with the Smart Digest combined with the Vanquish. And I've also shown that, and I think you've probably seen a lot of information about the Vanquish and what a great instrument it is. But with the higher flow rates, we can really push those levels down, and then using some of the newest column technologies, that's going to really let us get better and better data, and more precise data as we push these flow rate, or push these analysis times down to the limit. So I guess 6 times more speed is what I figured we can at least achieve just using the Vanquish. And then once we factor in the Smart Digest, we can go from now days to do a digest and get data to hours to do a digest and have data for clients by the end of the day. And then I'm just going to thank Charlie Althea, who was our scientist in the lab who oversaw the project for Althea, and then Lena Ceballos. I think they're both in the audience now, so I didn't have a picture. I should have had a picture, but you guys can raise your hand. If you want to talk to them, they're superstars. And then John Ferguson was the application scientist who came from Thermo to help us out. So he was a great guy. He spent a week in the lab, really knowledgeable, and I had a great time working with him. And I know Charlie learned a lot from him, as well as Lena. And then Christina Ginty, also fantastic to work with, really knowledgeable about everything, and really just a pleasure to spend the week with. And then, like I said, Z, I really have to thank her for putting all of this together and giving us the opportunity to be here this morning. Kelly Broster, and then Janine Pippett and Rowan Moore, who you may not know, but I've been doing some work with them for years, and they've really been great collaborators with Althea and helping us to get out and do some more work that we wouldn't have the chance to do without some support from outside of Althea. So that's all that I have. Thank you, and I appreciate it. If there are any questions, I'm happy to try to answer them, but I think if there's specific Smart Digest Vanquish questions, I'll probably refer that to someone with more experience in that from Thermo.
I'm the technical support guy for consumables, so if you have some questions, feel free to ask me. I'm the guy in the hat.
Great, thank you.